Hello everyone, I'm Tamás Lovas from BME, Budapest University of Technology Economics, and this is the module Capturing Reality. I'm from Budapest, from the biggest technical university of Hungary, and I'm from the Department of Photogrammetry and Geoinformatics. My research area is aerial mapping, photogrammetry, point cloud-based technologies, geoinformatics. So in this module, we will glance through the reality capture technologies. We will compare the various methods, and we will learn about the applications in engineering workflows. So I will show you some use cases also. Okay, in this introduction session, I glance through all the data acquisition technologies, and in the forthcoming sub-modules, in the forthcoming short videos, for 3 to 7 minutes each, we'll learn about remote sensing, aerial mapping, including drone photogrammetry, laser scanning, terrestrial laser scanning, mobile mapping, and scan-to-beam technologies. So when we are talking about data acquisition, we are talking about gathering geometric and attribute data. We can distinguish these technologies based whether they are on the ground, so terrestrial technologies, whether the platform is moving, so these are the mobile technologies, or the platform and the sensor is in the air, these are the airborne technologies, or in the space, these are the spaceborne technologies. We can also make difference before whether we are capturing the geometry of an object, like a statue or a sculpture, or a facility, like a power plant, or a building, or linear features, like roads and railways, or utility networks, or a whole area, for example, for topographic mapping. And we can also categorize or classify the data acquisition technologies based on the output, whether we have a coordinate of a point, or we gather a point cloud, or the output is a mesh, so a surface model, or we derive vector products, for example, for architectural survey, or we have 2D or 3D data. Based on the actions, we can set out designed objects on the field, on site. We can survey facilities, we can survey the topography of an area, we can make engineering surveys or measuring deformations or displacements, and we can use these technologies for quality assessment. So if you want to check what are the geodesy and surveying fields, I indicated in blue the ones we are dealing with in this module. So these are the photogrammetry, remote sensing, laser scanning, and mobile mapping. So if we start from land surveying, all the civil engineers and architects are learning something about land surveying. So at the beginning, we used only theodolites. So we measured vertical and horizontal angles, and that's what we use for spatial data acquisition. In tachymetry, we started to measure the distances. So we started to collect polar coordinates. In the total stations we are using now on site, we are measuring horizontal and vertical angles and distances. With leveling, we can measure the height differences between 2 points or between multiple points. And with GNSS receiver, with global navigation satellite systems, we can define the geodetic coordinate of any kind of point on site. In laser scanners, they bring the point clouds in our life, so we are gathering a huge amount of data with laser scanners, and we can also use cameras for data acquisition. And in the last 10-15 years, we are also deriving point clouds for images. So that's what photogrammetry does nowadays. And where to put the equipment, what kind of devices we are using. We can use tripods, we can put laser scanners, cameras, total stations on them. We can use poles, we can use it for GNSS measurements. We can put the sensors on mobile platforms, we can mount them on mobile platforms. We can use UAVs or drones. Unmanned aerial vehicle, UAV stands for unmanned aerial vehicle. So, and we are using them in the AEC industry, or we can use obviously more sophisticated aircrafts like helicopters or conventional airplanes for airborne mapping. So in summary, there are new technologies on the ground. We have started to use even new technologies, new platforms. So we put the same sensors on different platforms, like we put cameras on the UAV, we use cameras on the ground. We are collecting even more data. We are collecting big data, so the big data management is a high issue. we have less work on field, so we are faster on site, but we bring the work in the office. So it doesn't mean overall we save too much time. But we started to automate processes. Even think about the collection is highly automated, the pre-processing of the data, the resampling of the data is partly or fully automated. I will glance through in the forthcoming videos these processes. So the main question what you can raise in your field, which of these methods do you use in your field, and where is reality capture underused? Where is reality capture underused in infrastructure project, for example? So I will show you technologies that are not used in all areas of the ASC industry, but they can be considered mature in other parts of the industry. So that was the first submodule of the reality capture. We will now run through on the forthcoming videos on remote sensing, airborne mapping, laser scanning. I will show you use cases, and we will also learn about mobile mapping and scan to beam technologies. Thank you for your attention. See you next time. Goodbye.